everyone, please look at the board. On the board is a question from electric circuit. Before we start to solve this problem, I want us to know that electric circuit is made up of three basic parameters. Number one is, let me write it out as data. Number one is the voltage or the potential difference. Voltage, it measures the potential difference in the cell given by V. Number two is the current in the circuit, the current that is flowing in the circuit given by I. And finally, number three is the resistance. It is sometimes called load. It resists the flow of current in the circuit given by I. These three parameters are the basic components of electric circuits, which means when these three parameters are connected either in series or in parallel as the case might be, then the electric circuit is said to be completed and it will begin to give out power, which we know as electricity. Which means when we talk of power in any electric circuit, we are talking of these three parameters. That means power, electric power is equals to what? IV. I stand for electric current, while V stands for the voltage. And the power again, I always tell my students, there are always many formulas, more than one formula for solving problems in physics. The formula you choose depends on the data given to you. So power is still power is equals to what? V square over R. Yes, power is equals to V square over R. R is resistance. And the power is still, another formula for power is equals to I square R. Yes, power equals to I square R. These are the formulas for power. Now let's read this question to know what is given to us and what is expected of us to do. I read, a 40-watt instrument has a resistance 90 ohms. On what voltage should it be operated normally? A 40-watt instrument, just know that the instrument is an electric instrument. It might be electric heater, electric cooker, electric whatever. It is an electric instrument for it to have power. Okay? It said it is a 40 watt, which is the power. Power is measured in watts. The power in this instrument is 40 watts. Okay? And it says it has a resistance of 90 ohms. The resistance of the instrument is 90 ohms. It now asks us, on what voltage should it be operated normally? Okay? And now look at the question again. What is given to us? First, they give us power. So we write power. I want to solve it here. Write power. Okay? Equals to what? Equals to 40 watts. What other thing did they give us? They give us resistance. Resistance is measured in ohm. Resistance 90 ohms. So I write resistance equals to 90 ohms. Okay. What do I do next? I come to the formula for power and now look and check the formula that will suit the data given to us. As I say, that the formula you use depends on the data given to you. So as I check, the first formula, power equals to IV, have current and voltage. And there is no current in this question. So, we'll not use it. We come to the second formula, power equals to V square over R. Look at it again. We are not given V, but we are asked to obtain the V, which is the voltage. So there is provision for V. Again, we are given the resistance, which is 90 ohms. So we use the second formula. It suits the question. Let's use it. The third formula did not suit the question because the third formula has the current. So we use the second formula. So we have power is equals to V square over R. Write it. Power using the second formula now is equals to V square over R. We are using this formula. What do we do now? We substitute the data, the information given to us into this formula. And the first one is power. Are we giving power? Yes, we are giving power equals to 40 watts. So we say 40. This 40 for power. We are substituting the value into the formula now. Right, equals to is equals to V square. Are we giving V? No, we are solving to change the value of V. So we still write it as V square over R. Are we giving our R? Yes, we are giving our R as 90 ohms. 90 resistance is measured in ohms. Okay, so what do? We cross multiply. When we cross multiply, okay, let's dash this 40 over 1 so that it will be in uniform, so that it will be in fractional form. The one doesn't make any difference, just to make it to be in uniform shape. Good. So what do? I cross and multiply. When I cross and multiply, it means this times this and this times this. I'll start with this. It will be 40 times 90. I have 40. This 40 times 90 times 90. This 90. Put the equals to is equals to what? V square times 1. I'll write it out. V square times 1. Okay. I want to finish it this side. Let me finish it this side. So I'll say 40 times 90 will give us what? 4 times 9 gives us 36. So I write 36. Carry this 2 0. Put there. Come 0 0. Put the equals to is equals to. V square times 1 gives us what? It still gives us V square. Anything multiplied by 1, it's still the same number. So I still have V square. Okay. What do I do now? They are asked us to get V, not V square. So to remove this square, I will square both sides. So I will say, let me write it out again. I'll write it out. This number 3600 equals to V square. So I want to square both sides now. I will square this one. Maybe I stand here. So I square 36 square gives us what? 6. 0 0 gives us 1 0. Is equals to, according to this side, I say cancel. What remains is only V. Is equals to V. Which means our V, this V, is equals to this 60. Answer. So you have answered the question. On what voltage should it be operated normally? It should be, this instrument should be operated on 60 voltage normally. It should be operated on 60 volt. Let me put it. It should be operated on 60 volt normally.